Good morning. Good morning, good morning, good morning, and welcome to Carl Franklin's Blazor Desk Show. We're going live on YouTube and on Twitch right now. And hopefully you guys will show up. I'm hoping you'll show up. If not, it'll be on video later. So I'd like to officially welcome everybody to the Blazor Desk Show. Tell you what we're going to do here. I'm going to share everything I know about Blazor. I've learned a lot. A lot has happened, even recently, just in the last week or so. So be prepared to drink from the fire hose, and I want you to know that you don't have to take pictures of the screen. You don't have to, write down URLs and stuff. All you got to do to get all the information and the code and the materials and the links for this is just go to blazordeskshow.com and download it there. There's a hands-on lab that walks you step by step through building all the stuff that I build here. And also this presentation in PDF format is available up there. So go to blazordeskshow.com and get your free stuff. It's all good, folks. So what is Blazor? Well, Blazor started as an experiment that Steve Sanderson did and showed off at NDC Oslo a couple of years ago. And he wanted to, he knew about WebAssembly, which was a newish kind of virtual machine that all the browsers support. And people were writing compilers for it, and he said, you know what, there's no reason why we can't have C# in there too. And it just snowballed, and it became a product, and it became part of the .NET framework, .NET Core. But along the way, it was pretty obvious that Blazor was much more than just running C# code in the browser, that Blazor is a component model. And no audio on YouTube. Okay. I am definitely streaming to YouTube. I don't know why there's no audio. You guys let me know how that works out, okay? Blazor is really a component model where you have... Okay, good. They hear me. Where you have essentially markup, which is HTML, and code, which is C# together in one package, and you can make these reusable components. And, there are web components for every major UI platform, including just vanilla HTML and JavaScript, but what makes this different is that it's C#. And, enterprise developers who use C# have been waiting for something like this ever since Silverlight. And that brings me to Silverlight. There's a lot of people that are asking, is this just the next Silverlight? And the answer is no, it's not. And I'm specifically talking about WebAssembly here. There's a huge difference between, and I can see why people would conflate Silverlight's past with Blazor WebAssembly's future, because they both kind of achieve the same end goal, which is C# code running in the browser against markup. The biggest problem, or the only problem Silverlight had, was that the only way to make it work in the time of Silverlight was through the plug-in model that browsers supported. All right? And there was another very famous UI framework that was being used in browsers with the plug-in model at the time, and that's Flash. Everybody remember Flash? Yeah. Flash was, I can't believe that in the 2000s they were still teaching Flash in high school in terms of, web programming stuff. But anyway, Flash was a problem for Steve Jobs, and a real problem, because it was introducing malware to iOS, which, something that Apple users were not used to. I mean, malware, that's like Windows stuff. We don't have malware. But yep, malware was getting into the iOS Safari browser. And also, it was draining the battery of iPhones and iPads. People were watching movies and their battery was going whoosh. And so he famously wrote this white paper, Thoughts on Flash. And in that, he basically said, we're not going to support the plug-in model. He didn't say Flash, he didn't say Silverlight, but it was because of Flash that iOS Safari didn't stop supporting the plug-in model. And a lot of other browsers followed suit. And Silverlight was sort of a casualty of the plug-in model being so crappy. So that was really the only problem with Silverlight. There was no technical problem with it at all, except that it was insecure because of the plug-in model. So WebAssembly is definitely not that. WebAssembly is a virtual machine that lives in every major browser, and by major browser I mean browsers that are currently in development and being updated regularly. Internet Explorer is not one of those browsers because Microsoft jumped over to Microsoft Edge. And Edge supports WebAssembly. So does Safari on iOS. So it isn't something that is an option in browsers. It isn't configured differently from browser to browser, as far as I know anyway. It is baked in there. And the cool thing about it is, for the first time, we're able to run different languages in the browser other than JavaScript, which is great. And let me tell you something, everybody loves this. So WebAssembly isn't just for C#. Rust runs on WebAssembly, Golang runs on WebAssembly, the Python runs on WebAssembly. There's a whole bunch of companies that are making compilers now for this virtual machine. It is a cross-platform virtual machine. It fulfills the promise that the JVM and the CLR sort of had, which is this cross-platform, virtual machine where you can run just about anything in there. It also has the same security walls as JavaScript, the same security restrictions. So it isn't like you can run code in a browser that's going to screw things up. So getting back to the component model, this component model, the markup in code, is really, really elegant. And you'll see as we start getting into it just how beautiful it is and how much you're going to want to write code for it. The thing is that same markup in code can either run in a server-hosted model or in the browser. So there's really two hosting models for Blazor. The first one, Blazor Server, was introduced in .NET Core 3.0. And so if you have .NET Core 3.0 SDK and you have Visual Studio 2019, you can create today a server-side Blazor or a Blazor server app. And all of that markup in code is going to run magically, and we'll see what that magic is in a minute, on the server. You can take that same markup in code and create a Blazor client application or a Blazor WebAssembly application that runs the code, same code in the browser. But here's the thing, you have to install a preview package because it isn't currently shipping. However, the component model itself is completely done. It's baked. It's solid. So that means the markup in code that you build today, even with a preview of Blazor WebAssembly, is going to run when Blazor WebAssembly ships, which will be in November with .NET 5. But you can't combine models. You can't combine models. You wouldn't want to combine models. This is a SPA framework, okay? So like a SPA framework, it's really for UI, right? Oh, okay. Somebody from Twitch says, I thought Blazor WebAssembly is shipping in May. No, it'll be baked in May. In other words, all the plumbing code, you know, behind it will be solid. So, but that doesn't mean that it's going to ship. It won't ship until .NET 5 in November. Good question. A lot of echo. Oh, I know why. I'm sorry, guys. Here's the thing. There, that should be better. I've been doing music concerts with my guitar. And yeah, I have reverb and stuff for that. So it's probably a lot better now, right? I'm sorry about that. Gigantic sound. Blazor, Blazor, Blazor. Okay, cool. Thanks. It's the joys of doing live events. But all right, so you really can't combine models, nor would you want to combine models. Now, you can build a Blazor server app and a Blazor client app with the same code and markup at the same time. I'm going to show you how to do that. But at the end of the day, your application is either going to be a Blazor server app or a Blazor client app. So hopefully within the next couple hours, you will understand the difference between these two hosting models and be able to make an intelligent decision for your own projects, which one you would use. All right. So right now, as I said, you can just get Visual Studio 2019 and you can create a Blazor server application, as we're going to do in just a minute. But if you want to get into Blazor WebAssembly right now, you can do that. You need to install the latest Visual Studio 2019 preview. And by the way, the community edition of Visual Studio works just fine. That's the free version, okay? You don't need professional or enterprise. Of course, they're going to work great, but yes, it was dramatic. The echo. I'll never hear the end of that one. Literally, it's going to have a long decay. So you have to install the latest .NET Core SDK 3.1 and the latest Visual Studio 2019 preview and install the Blazor WebAssembly template. Now, the last time we did this, we were talking to Dan Roth, and Dan Roth was like, we just dropped a new one today. I'm like, oh. So I had to scramble to, it wasn't a big deal. I just had to update my code. But there's some new things in there now. So just since the last Blazor Desk show, things have changed. But anyway, if you just Google Bing Blazor WebAssembly Preview 3 or 3.2.0 Preview 3, you'll get this link right there. Dan Roth announced it, and all the instructions for installing everything are right up there. So here, let's just actually take a look online. I'm going to pull up Visual Studio, and we're going to create a new project. I'll just create a Blazor server project, and we'll go through the sort of quintessential or canonical example of Blazor server. I'm going to call this app Blazor server, and I'm going to put it in my Blazor Roadshow directory. Now you can see I have the ability to create both a WebAssembly app and a Blazor server app because I have installed that WebAssembly preview template. Anyway, I'm just going to pick Blazor server. We're off to the races. And just going to show you over here that this is just a regular ASP.NET Core web application. In fact, there's nothing special about this except that it has the right plumbing in startup, and it's got some pages, some Razor pages. You can add Blazor pages to an existing .NET Core, ASP.NET, MVC, Web API, whatever, just with the right middleware. It's very easy. So there's a couple of pages here. There's index, which is like a static demo. Then there's a counter, which updates a counter with a button click. And then there's fetch data, which gets some data. So I'm just going to run this. Bring back the God voice. Sorry. It's a little early in the morning for the God voice. For me, anyway. So, hello world. Now remember, all this code is running on the server. Let me show you that there's just this interaction here where you can click a button and increment a count. And I don't know if you can see that, but this counter is incrementing right there as I click this button. Looking at the code and the markup, it's really easy. You have this HTML, right? You have a header, counter, and a current count with this @ sign. So this is the Razor syntax where you can inject variable values right into your markup. And here's the variable right there, private int count. And then on click, we are calling increment count, which is going to increment the counter, obviously. But one thing about this on click you'll notice is that it uses an @ sign, on click. Now, if we didn't use that @ sign, this would be a JavaScript on click. However, that tells Blazor that this is to run on the server. So unlike web forms, there isn't any run @ equals server. There isn't a lot of ceremony. It's just a nice, easy blend of the Blazor code into the markup. So I want to show you this file right here, _host CS_HTML. When the application routing kicks in, this is the default starting point. Okay, doesn't have to be the starting point, but it is the default. So take a look at what's in here. The head just has some style sheets, the basic stuff that's in the header. All the stuff in the body, look at all this is just for handling errors. And then we have the Blazor JavaScript stuff itself that hooks the DOM and realizes what it needs to do for UI. But most of it is right here in this app component. In fact, this app reference right there is all of the markup in the code in the Blazor project. All of it is right there. But I just wanted to show you this Blazor server JS is running in the browser. Okay, this is a browser side script tag. So that's going to run in the browser and it's going to hook the DOM. What's going to happen is it sees that this button was clicked, says, oh, there's this @ click here. So we're going to send a message to the server, and how it does that is with come on, here we go. Signal R. Yeah. There's a Signal R instance in a hub built into this application, and there's going to be a one-to-one communication between every client and the server. Signal R is a WebSockets implementation. It's open source, and it's typically used for a one-to-many sort of broadcasting, like the canonical example is a chat application, where one client sends a message, it goes to a hub, the hub disperses that message to all the other clients, and so you've got this chat. But it doesn't have to be used that way. So they've chose Signal R because it's very robust, and it works across a wide variety of browsers and technologies and firewalls. and it's very reliable. So that happens, right? We go through SignalR back here to the client. Sends a message to SignalR, hey, they clicked the button, right? On the server, the hub says, oh, I need to run this increment count. And so it runs this server side, and you can see it could put a breakpoint right here, and it'll just click there, it'll just stop there. Increments the counter, but then it says, oh, well, that affects the UI. So how does all that stuff just happen? Turns out that Blazor server has a map or a graph of the DOM of each client in memory, and as it basically plays the changes through the DOM on its graph, looks at the difference, and sends the difference down to the browser in form of a binary message through SignalR that says, hey, you need to update these fields or whatever. And it just happens so seamlessly without any ceremony and without any kind of plumbing code that you actually have to maintain. And let's face it, that has been Microsoft's strength throughout the story of development on Microsoft languages and technologies, that they want to make it so that you don't have to be mired in the plumbing. Whatever plumbing we can push down into the infrastructure and take off your shoulders for the responsibility of maintaining it or dealing with it, the better. So that's what you have here. SignalR is the magic that makes this happen. Now, let me show you exactly what's going on here in the browser, network-wise, during a Blazor server application. I've disabled the cache, all right here, and I'm going to press the record button. And let's go to the counter page, and I'll hit Control F5 to reload everything. Well, this is very interesting. Not a whole lot of data was transferred. 161K. Really fast startup. All right. All this stuff over here, right? You've got the CSS, some JavaScript, all that stuff. But look at this guy right here, _Blazor, and you can see the type is a WebSocket. So this is the SignalR connection. And if you click that, and I'll just clear all the messages here and click the counter again, and we'll go and look and see what happened. Right there, first of all, is a binary message sent over SignalR, 291 bytes. That is essentially the browser JavaScript right there that hooks the DOM and says, hey, user, click the counter button. Increment count runs on the server, and it sends back another binary message with the update to the DOM, 148 bytes. Pretty efficient, right? And then the browser sends back 27 bytes. I'm not sure exactly what that's for. It's probably like an acknowledgement, like, okay, browser has been updated. We're good. So that's not a whole lot of data. And that's what I want to get across to you with this demo, is that it really is very efficient. So this is exactly a page that explains what I just showed you. Oh, there is one other thing on this page you should take a look at, and that is the advanced logging of SignalR traffic. If you want to get a little bit more of a detailed look into what is going on there and the messages going back and forth, you can hook that in the debugger. And there's a blog post that I wrote there. If you just go to blog.appvnext.com, you can search for it there. All right, let's talk about scaling, because obviously if all your code is running on the server, that server has to be beefy enough to be able to handle the load. Here's a question. Is there a limit on how much data we can send over SignalR in one transaction? There isn't a technical limit, but there's a functional limit. So, in other words, you will find that if you try to do something like a file transfer or whatever, it's going to go really slowly because there's a whole lot of hops and things, and data isn't so efficient as to take big chunks and send it over. That's not what really SignalR is for. It is for, as the name suggests, signaling. You know, small bits of data. That said, you know, it can handle anything that you functionally in your application would want to send. You don't want to send millions of rows. In fact, that's a point right here on this slide. Because of memory, you don't want to keep a lot of data going back and forth and keep it in memory. Does that mean file upload functionality is not going to work as good? No, that's not what it means. First of all, the file uploading stuff in Blazor isn't there yet. But there are third-party controls like DevExpress that have file upload controls, and they don't use SignalR. I mean, that's not what it's for. They're API-based, right? Web API. So memory is obviously the biggest limiting factor here. There's a minimum of 85K required on the server for every concurrent connection. And that is like the overhead of SignalR, the overhead of Blazor, the DOM, all of that. And that's just a minimum. If you start, building a big project, that could bump up 100K, 200K. So you really have to be cognizant of how much memory your pages are using. And by memory, I mean, you can equate that to object lists, lists of objects that are going to be displayed in the UI. WebSockets are also a precious finite resource, and the limit is based on memory and CPU. Now, if you're really interested in getting the most scalable solution for SignalR, you can use the Azure SignalR, and I realize you can't see this, but the Azure SignalR service. And if you go to that link, sockets are also a precious finite resource, and the limit is based on memory and CPU. Now, if you go to that link, you will see an article that shows you how to completely remove the SignalR portion of Blazor Server and put it into an Azure service, which scales indefinitely depending on how much money you have. Okay? So let's talk about how many users you can expect realistically to be able to support. Well, Microsoft did a test. I pilfered this slide from Dan Roth from .NET Conf. And essentially what it says is they did a test for latency, appropriate latency, which they deemed was about less than 200 milliseconds. In other words, from the time you click a button to the time you get a response, if it's more than 200 milliseconds, the brain is kind of like, did I do that, or is something else happening? So with active concurrent clients, they were doing 1 click per second, and this was a real application. The overhead, if I remember, was 165K, something like that, 185K per client. But it wasn't just a counter click, is what I'm getting at. A real application, and they found that with the standard D1 V2 configuration of server on Azure with 1 virtual CPU and 3.5 gigs of RAM, they were able to support 5,000 plus comfortably. So 5,000 concurrent users, and that's without any SignalR scaling or anything. That's just in the box. But if they bumped that up to 4 virtual CPUs and 14 gigs of RAM, they were able to support 20,000 on 1 box. So again, available memory is the primary bottleneck. Now, it also brings up the question of, well, what if we want to scale out? Scaling up is one thing with one server, but scaling out, if I had, can I run these in, you know, Docker containers, for example? And the answer is yes. It's really just an ASP.NET Core server application. So you could have a cluster, but that means that the state now has to move outside. First of all, you're going to have to use the Azure service for SignalR, and the state also has to be in some service that's outside the box, right? All of the state. What variables are you keeping in memory, which means what is being shown in the UI, and I'm going to show you how to do that too. So let's talk about the upsides and downsides of the server hosting model. Well, on the upside, the download size is significantly smaller than with a Blazor WebAssembly app, as we'll see in a minute. You're running on the server, so you have all of the things that are accessible to you on the server, right? You can call into databases directly. You can call services in the cloud services that have keys, because all of that stuff is kept away from your user. It's already on the server, so you can take full advantage of that. Thin clients are supported, so browsers that don't support WebAssembly, like Internet Explorer. IE 11, if your users are still using Internet Explorer 11, then there's a polyfill that is required in order to use Blazor Server, but it's easy to do. And this is important to some people. The app's code itself is not shipped to the clients. It's not running in the browser, so the code is completely protected and nobody ever sees it. And that's important to some people. So on the downsides, there's added latency because of the round trip to for every UI interaction through SignalR, right? There's also no offline support, because remember, this is a UI framework. We're not using SignalR to go fetch data from like an API or something. This is a UI framework. So if that SignalR connection is broken, internet goes down or whatever, your app is useless. It stops working. Scalability, the challenges I just talked about, you have to think about memory and WebSockets, whether you're going to scale out or not. And it does require a server. So an ASP.NET Core server is required to serve the app. There isn't any shipping it off like you can do with HTML and JavaScript, or any of these other frameworks. You can't just wrap it up and ship it through a CDN, for example. Question, in case of horizontal scaling, what happens to connections made to the second app when it scales back down? How could I transfer their state to the working app? Well, the answer is to not have the state in the app itself, but to move it off somewhere. And if you've done any web forms, you know that the session object sort of represents the state. And there were two ways that you could do that out of the app itself. One is use a state server, just a dedicated server for the state, and the other is a SQL server. You have far more options with Blazor. In fact, there isn't any kind of built-in, prescriptive state management stuff. So there's no session. However, I can show you how easy it is to build your own classes that you can use for state. And then what you do with them is up to you. But we'll talk about that in a minute, I promise. So any questions before we move on to WebAssembly? Any questions on the Blazor server hosting model? Any other questions? As I pour myself some coffee in my .NET Rocks mug. This is an old one. And guys from Dev Express are here in the house. Don Webier is there, and John Martin. Don will be coming on a little bit later to show off some really cool stuff that I think you're going to like. You mentioned file uploads via API. I assume Blazor will sit nicely with MVC in the same project. You assume correctly. Yes. Very, very easy. Just going to wait a minute because of the delay. I want to make sure that everybody has an opportunity to ask a question if they have one. But the Developer Express guys are out here. They're answering the questions, so if I don't get to it, they certainly can. All right, we'll move on. So the hosting model for the client is pretty simple compared to server, right? So the server, there's this round trip via SignalR for UI interactions, whereas on the client, all the code is shipped down to the client and it runs in the browser on WebAssembly. So that's the difference in the models right there, the major difference. We'll come back to that graphic in a minute, but let's go back to Visual Studio, and I'm going to add a WASM, as we call it, a WebAssembly project, to this same solution. And then let's watch the network traffic with that and compare it. So here's a Blazor app, and I'll call this Blazor WASM. Just going to add it to the same solution. Here's a nice little feature, undocumented feature of the latest Visual Studio. You'd notice my WASM has gone away. But if you just slip from .NET Core 3.1 to 3.0 and then back to 3.1, boom, it magically reappears. Undocumented feature. All right, and before I do that, I'm going to also, oh, look at this. Also notice that the scaffolding for a progressive web application, if I want to make one, is right here. I can check that off if I want to, but I really want to check this one off, ASP.NET Core hosted. Because if I don't do that, I get one project. And that one project, I'll be able to interact with Visual Studio and all that stuff. But there isn't any server that's hosting it. So if I want to create APIs, right, and I want to call those from my client, which you kind of have to do, right, for sensitive code, I would have to create a separate server, and then I would have to configure cores, and then it's just, you know. So what they did is they gave you the option here to create a server project that hosts the client application. And that's exactly what we're going to do here. And you also get a third project, which is a shared project where models go. I'll show you what this looks like here. I'm just going to take myself out for just a second so I can show you all these projects here. Look at the bottom, Blazor WASM shared. This is where the models go, and there's one for the weather forecast for the weather demo, the fetch data demo. Here's the server that is going to run first, and look, there's a controllers folder. So you know that this is a really good example and a good model for how to build a Blazor client application if it's going to call APIs. And that hosts this Blazor WASM client, which runs in the browser, and that's where our pages are, right? This is where all the Blazor markup goes, markup in code. Poof, I'm back. All right, so we're going to set Blazor WASM server as the startup project, and we will run it. And we'll take a look at the network traffic here. Let's compare and contrast. First of all, there's in the latest preview, there's a couple of great new features. And I know this doesn't seem like it would be a feature, but there's limited debugging that wasn't there before, just last week. So, and by limited, there are some limitations. They're explained in that blog post that Dan Roth showed about the preview here. So I'm going to press F12 again, bring up the network window, disable my cache, start recording, and do a control F5. And let's see what we get. Wow, look at all that stuff. Now, 6 megabytes transferred. First of all, before you freak out, that is with the linker off. So when the linker is on, say if you change it to release mode, the linker will be on, but it's really just a configuration. So with the linker on, this example is much, much smaller. Let me show you how much smaller. All I have to do is switch to release mode. And we'll do this whole thing again. Yeah, it's fine. All right, cache disabled. Press Control F5. All right, now it's only 1.9 megs transferred. So even if it was 5-6 megabytes, think about this. Gmail sends down 5 megabytes of JavaScript and HTML, and it hasn't stopped anybody from using Gmail. Angular, React, they all have these front-loaded systems that, because code is running in the browser, that's what you get. So let's take a look at what some of the files here are that got loaded specifically, and let's sort these by size. Look at this at the very top. .NET WASM. That is a mono implementation of the CLR that is compiled for WebAssembly because it has the .wasm extension. So that's a binary WebAssembly piece of code. And that is the CLR. On top of that, all of the DLLs, the assemblies that are going to run in a managed environment. This is actually a managed code environment running in the browser. And it's one of the only managed code environments that runs on WebAssembly. A lot of all of these other languages are compiled directly to WebAssembly. But we have the benefit of using a virtual machine, a CLR, Common Language Runtime. Can the user download those DLLs? Yeah, sure. But here's the thing. The user can view source and download your JavaScript too. So the same rules apply. This is for UI code. You're not going to embed secrets. You're not going to put passwords. You're not going to put database connection strings in there. So that rule applies. This is UI code. Good? So these are all .NET Standard 2.0 compatible assemblies. And of course, if we go over to Counter and start clicking, there's no traffic because it's all running in the browser. So let's talk about pros and cons of Blazor WebAssembly. On the plus side, the code executes more quickly in the browser. so lower latency. We don't have that extra hop to go to the server for UI. Offline support works fine, so a progressive web application is a really good idea when you're doing Blazor client. Progressive web applications, if you don't know what that is, you've got some reading to do. It's a way that a user can go to a website, see on a phone, a device, whatever, computer, and see an option to install to the operating system, essentially. And on a phone, it installs as an icon, and when you run it, there's no browser Chrome. It just runs as an application. And then, of course, you have the options to configure caching, so you can cache data and use it offline. It's really, really cool. Because it doesn't require a server for UI, you can distribute these applications with a content delivery network. And as I said before, any .NET Standard 2.0 C# code assemblies will run in the browser. On the downside, the Blazor client can't, well, it can directly access your database. If you're silly enough to ship a database connection string or usernames and passwords and have your client connect directly, I guess nothing's stopping you from doing that. But don't, okay? Don't do that. Friends don't let friends ship secrets to the browser. You know what? I got to change this. Debugging in Visual Studio not yet baked. Well, it's true, okay? It's there, but it's limited. So that's the downside right now. The next release, probably in May, will show significant improvements in debugging. And in May, it will be baked. And as I said before, the component model is completely baked now. What's not is the plumbing code, the underneath code. And so, but what it guarantees is that any component model stuff that you build today will run on the shipping version. And that's really important. That's why I think now is the right time to get into Blazor and to see what this is all about. Some people think this is a downside. I've already talked about it, but your code is shipped to the client. Sensitive code should run on the server, just as you would with JavaScript. This isn't really a downside. I just wanted to address it right here because your C# code is in the same sandbox as JavaScript. All right, so any questions on the WebAssembly component model we haven't already addressed? How can those assemblies be protected from disassembled and edited, etc.? You can do the same kind of things that you can do with assemblies right now, which is to obfuscate them. And obfuscation means that while they're not encrypted, like all the names are replaced, the symbols are rearranged, the control flow is moved around, so it becomes very hard to edit. But that is, you have the same problem with JavaScript, right? You can minify JavaScript, and that discourages some people. But hey, if somebody wants to download your JavaScript, change it, edit it, put it on their own server, and then call it and do something, they're welcome to do that right now. So you have the same issues with assemblies that you have with JavaScript. All right, so let's talk about binding. And binding in the Blazor component model has been greatly simplified from any other binding that you've seen, whether, and I'm not even talking about Angular and React and Knockout and all those guys. I'm talking about, WPF, Silverlight, even web forms, Windows forms, any UI platform that uses binding, you're going to see how nice this is. And rather than read this all to you and explain it through the slide, let's go back to Visual Studio and actually implement some of this stuff. So first of all, I'm going to turn it back to debug mode. I'm going to set Blazor server as the default startup project. Close all these files so we don't get confused here. And I'll go back to the index. And I'm going to replace the whole entire thing with this little snippet of code here. So here we have a message, a property, string property called message. And we could see, we've already seen one-way binding, which is just displaying data like this h1, or in the counter, value, right? But this is two-way binding, so this is the way that we can change it. We can input, we can use a form, or this input control right here, and we're simply using the @bind syntax and binding it to the message. So that means anytime we change the text in this input, we're also changing this string. And anytime the message string gets changed from within, it will update in both of these places. So @bind is a simplification of the bind syntax, meaning that the property that we're binding to, the property of this input tag, is the default property. But you can specify the exact property that you want to bind to. I think it's lowercase value, yep, with a dash. So this is the same syntax now, but I'm being a little bit more descriptive, a little bit more explicit. @bind dash value says bind to the value property, but it's the default property, so I don't really need to do that. Let's see what happens. Now with binding, there's usually an event that causes the change to ripple through the UI. And in this case, it's onChanged. So the onChanged event happens when an input loses focus. So here I'm going to press tab. And as soon as I press tab, we lose focus and the change propagates. Now here's the cool thing. You can actually change that onChanged event to something else with @bind::event equals. And then what is the event that is going to trigger this binding to update the variables? OnInput means every keystroke. So now what I've done is I've overridden the default event that makes the change, which is onChanged, and now every keystroke updates the UI. All right. So this is going to be very important when we do the next thing, which is we're going to create a component. This is the first time you've probably seen, first time you've seen me create a Razor component. We're adding a Razor component right here. I don't know if you can see that. But the Razor component is the base of all components, reusable components, and pages as well. In fact, the only difference between a page and a Razor component is this page directive right at the top. All right, so I will add this. I'll just add it here in pages. I'll add a Razor component called child component. And here's another undocumented feature waiting to finish initializing. So if that happens, you can just close it, open it again, and there you go. So here I've got a div at the top, and I've just added a little inline styling here. I'm giving it some padding, setting the background color to light gray, just so that we can really visually see what's a component and what's not. And I've got a heading to parent message, right? We've got this parent message string, and a button that calls something called update message. All right, so what is this parameter stuff here? Parameters And we just add this attribute here, parameter, to make anything a parameter. Parameters are, you can think of them as public control properties and events. So if we're making think of this as like a custom control, right? This is exposed to the parent, and by parent I mean index Razor, the thing that's hosting the control. And this is how events are handled. Look at this. This is really elegant here. An event callback of whatever you want to pass. So it doesn't have to be event args. We don't have to inherit from event args. We don't have to have a public event. We don't have to worry about threads. Like, there's so much good stuff here. So event callback of string, it's called message changed. Now, when we press that button, we're calling this update message. And by the way, anything that you want to make async, just change from void to async task. And now you can call await. So we're changing the parent message to blaze on. I should put my echo back on. Blaze on. And then we're invoking message changed asynchronously, passing parent message. All right, that's what this component does. Now, if we're going to call this component, let's change our code here again. The only difference is this right here. We've now added a child component just by defining it right there. And look at the binding. Remember, the bind dash means bind a specific property of this. So we're binding the parent message property of the child component to our message. Good. And now we're changing the event that updates that binding to message changed, which is the event callback parameter of child component. So now we don't even have to have a handler here, an event handler. We just say, hey, when message changed happens, update message, or parent message, right? That will update message, and that will update our UI. So we've got UI here, message, we've got it in the input, and we've got it in the component. All right, so check it out. The gray is obviously the component. So every keystroke, now you can see it's changing here in the parent, in my input, and in the component. But now when I change the message from within the component, boom, everybody updates. Huh? Pretty cool, huh? Very, very cool. Yeah, binding is really simple. And the whole component model, you can see where it's becoming really elegant. This child component you could have in a completely separate project and compile it to an assembly that you could now share with a bunch of other people, wrap it up in a NuGet package. In fact, that's what DevExpress and all these other third-party developers are doing. There's a whole market out there for these components that you just pull in through NuGet and you can just create them. Great stuff. All right, let's talk about state, because if we're going to have a Blazor server application and we're going to have a web farm or a cluster, funny, web farm is such an old, outdated, outmoded term now, but I still think of it as, you know, a farm. If we're going to do that, then we have to move state outside the application. So I'm going to start by moving state out of the page itself. That's the first thing that we have to do. And then we can talk about where we're going to store it. So let's go back to our counter example. And I don't know if I showed you this behavior or not, but If we say go to the counter and we click a bunch of times, and you can see the count is now 7. And then I go to another page like home or fetch data, and back to the counter, the current count has been reset to 0. And this is by design, because this is a, you could call it a module level variable. It exists on this page. This page gets initialized every time you navigate to it. It gets reinitialized. And check this out. Check out the component. If we wanted to do, we could do it right on the page here. Every page has a bunch of built-in virtual methods to control the life cycle. Here's 3 of them right here. On initialized, on parameters set, and on after render. And there are also async versions of these. So on initialized happens first, and you can override these if you want. And this is the first thing that happens. You will find that parameters get set. Some parameters are set. Like if I was here in the child component, and I looked at this, and we put a breakpoint here, the value of parent message would be set, but some other things wouldn't be. So then there's another one called on parameters set. All of the parameters have been set. We are ready to render. So there's 2 stages to that. And also on the server side, if you change the render mode from server pre-rendered, well, if it is server pre-rendered, the other option is not pre-rendered, just server. But if it is server pre-rendered, which is by default, this is gonna, where is it? This event, if you call it an event, this method is gonna be called twice. Once before the client connects, and then once afterwards. So that on initialized happens first. All of the module level variables are blown away, and then on parameters set, and then there's one that happens after the page is rendered. But anyway, let's get back to our current count here. So I want to move this, which you could think of as the state, out to another class, that we can make that class or an object of that class exist outside the page so it won't get blown away. So I'm going to call it app state. And app state is just going to have one, one property, count. And now if I can control the life cycle of that app state by adding it as a service in my startup.cs, configure services. You can see there's already one added here, weather forecast service. But if I say services.add scoped app state, now I can inject an instance of app state, whatever that is, whether it's a singleton or scoped, I've set it to scoped, in any page and access it. Now the difference here is a singleton, we get one instance that's shared among all clients. All right, good for a data service, not so good for client data, session data, if you think of it as session data or state. For state, you want to use add scoped. And a scoped service means that every client gets their own unique instance. Different. So now when you inject, and I will inject that app state into the counter page, this isn't actually creating an instance. This is injecting whatever instance we have already got because we've added it as a service. And now I have access to it. So on all the pages where you want to access the state or session data, you might want to think of it as the state data, you put it all in app state first of all, wherever it goes, complex objects, whatever, as long as it's serializable, which most things are. And now you inject it where you want it. And so now we can completely get rid of that current count and change that to app state count. Also up here, app state count. And I'll run this again. Go to the counter, press increment a bunch of times. You can see it's 6 right there. And I'll go back home, blah, 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 back to my counter, and it's still 6. Now, if I want to access that number from another page, no problem. I just inject app state and I access it. So now, what if you want to persist that, right? There's no rules. You do whatever you want. You can take that, let's jump ahead. When we have an authenticated user, that user has an ID, whether that's an email or GUID or GUID or whatever you guys say. That ID is how you would look up the state. So you would put an ID property there, whatever it is. All of the UI state goes in there. And then that whole app state can be serialized and deserialized. You can look it up on initialization, on initialized. And all of your state is right there. All of your pages can access it. And then whenever you make a change to it, you persist it somewhere outside of the application. So that's about all I want to say about state. Also, I have this blog post that you might want to take a look at. It's a it's a shopping cart application, very, very simple shopping cart, where I take the state, which is the shopping cart, and I store it in the browser's local storage. And that is a technique that Steve Sanderson showed off, and his guidance is you probably only want to store a couple of K in local browser storage. You don't want to overload that with a whole lot of stuff, but we really are talking about UI here, right? So let's say the user is filling out a form, and as they go through that form, they're applying for, I don't know, COVID-19 protective gear, let's say. And so as they go through that form, every time you update, you get an update to those form values. You can put that in the state and go persist it, right? So, oops, I closed my browser. Now I come back. After I'm authenticated, I know what page they were on. That could be part of the state too. Navigate to that page, and all those values, which we were binding to, are in the state, and they're right there. So they don't have to get to the end of the form, blow it away, and then, I got to type all of that stuff in again. So that's about all I want to say about state. Check out that shopping cart example. You can download it and use it. All right, this is perhaps the coolest thing I'm going to show you today, which is how we can develop a Blazor server and a Blazor WebAssembly application at the same time. We're going to talk about authentication and authorization soon, so I should be able to answer those questions then. So this is the steps that you can take, but I'll show you again in Visual Studio rather than reading slides to you. All right, so just to recap here, what we have is a solution that has a Blazor server application in it, and also a Blazor client application, which is hosted by a Blazor WASM server. So we have both of these. And this is the WebAssembly project right there, Blazor WASM client. So what I'm going to do is add a reference from the server to the client. So this will be a project reference, right? Add a project reference. So on the server, I want to be able to access Blazor WASM client and also Blazor WASM shared. I want to check both of those off. The shared project, remember, that's where models would go, that kind of thing. Anything that needs to be shared between the back end and the front end. Okay. Now let's go to that underscore host CSHTML. This is on the server, remember? And I'm going to change, remember I told you that this app object right here represents all the markup and code in your project? Well, I'm going to change that to Blazor WASM client app. And I don't want to pre-render, so I'll change the render mode to server. Now when I run Blazor server, it will load the code from Blazor WASM client, the code in the markup. But it will be running on the server. Follow me? So now what I want to do is change the startup projects to multiple projects. I want to, when I press F5, start Blazor server and Blazor WASM server, which is going to run the Blazor WASM client. So we're going to have two browsers. One running on the client in the browser, another running code on the server, but it's the same code. So let's see what happens here. All right, Blazor WASM is the one on the left. So this code is running in the browser. Blazor server is the one on the right. This code is running in the server. Let's just go through these. Here's the counter. That works just fine. And I can fetch data, and that works just fine. By the way, this is calling an API. All right. Here's the counter. Works fine. What about fetch data? Boom. Well, let's find out exactly what happened here. First of all, take a look at this. An unhandled exception has occurred. See browser dev tools for details. If you're in debug mode, you're going to see this. If you're in release mode, it's a little more professional. But still, I don't like that message. I don't like my users pressing F12. But let's see what happened. So here's the deal. On the server side, there isn't any systemnet HTTP client. Well, why? Why is that? Let's take a look. All right, first of all, let's go to the pages in the client, because this is where we're calling fetch data. And we're injecting an HTTP client because that's how we're calling the API. The API is in the controllers folder on Blazor WASM server. These have the same URL base. They're running on this is, the server is the only thing that has a URL. So this API is just an API controller. And in the client app, we're just calling that as a relative URL. So that's one problem. The other problem is the one that we just saw, this HTTP client, the server doesn't have access to that because it doesn't need to. When we run this on the server, take a look at fetch data, we're just injecting a weather forecast service. Because we're on the server, that exists just as a class. And you actually saw when we injected that, right? Weather forecast service is just injected as a singleton. So our fetch data doesn't use HTTP, so it doesn't have access to it. So here's what we can do on the server side is add a service. HTTP client. And then in my fetch data, I can, no, you know what? We're not even running this code. So now in fetch data that runs on the client, because that's where the code is running, right? I mean, the client code is running on the server or the client, right? Now we'll have HTTP, but it's going to complain about this weather forecast. That's not a URL that it understands. But the error isn't going to be an HTTP error now. Here we go. Fetch data, press F12. And now the error is the URI must either be an absolute URI or the base address must be set. So we got rid of that first error, but now we need to make this a fully qualified URL. And to do that, let's find the in launch settings on Blazor WASM server over here under properties. Let's find the SSL port. There it is right there, 44394. Now I can, that's the wrong fetch data, here it is. Change this to HTTPS localhost : 44394 weather forecast. And just to show you what's going on here, I'm going to delete all the files in the pages, except for host, obviously, on the server side, just in case there's still a doubt in your mind that we're running the code in Blazor WASM client on the server. All right, fetch the data, and it works. Now we can do the same thing on the client. It doesn't matter if we have a relative URL or not. It's the same place. And there you have it, man. The same code base running in both hosting models at the same time. And you would build out your UI in Blazor WASM client now. The moral of this story is that you have to have the same resources available in the environment where it's running. That's why we had to add systemnet HTTP to the server environment, because it didn't have access to one of those, whereas in the browser it does. And also we have to write our code such that there isn't any assumption that we're either running on the server or the client. Interestingly, JavaScript is also runs in the environment, right? Because it runs in the browser. So in _host CS HTML, if you have JavaScript that you want to run, you put it here, right? And on the client side, that would go in www index.html. Looks a little different. App just says loading, right? Because this isn't a server-side application, but script goes here. So let's say I wanted to write, I wanted to do some JavaScript interop, which we'll talk about in a minute, but I want to write it so that I can make a call to this method, and it's going to return either, hey, I'm on the client, or I'm on the server. You could do that very easily. It's just the same name, method, but one, on the client it will return, hey, I'm on the client. On the server, return that. And then when your code accesses it from either environment, you'll be able to know where you're running. Here's a question. Is it possible to combine the client-side offline mode with the needed features and server-side speed for more nice-to-have features that you don't need offline? So, and Don's answer is correct. No. You either want to run one or the other, as I said in the very beginning of this. However, I can see an issue. I can see a thing where you have both of these available, right? And you have the server that serves the client application. And if it notices that you're calling it from Internet Explorer, it would redirect you to the server-side version. But it would have different URLs, obviously. So it's, you know, 6 of one, half dozen of the other. Okay, let's continue on with a demo of an application that is completely filled out called Band Booker. And the things that we're going to learn here, I'll come back to this slide, but these are the techniques that I'm going to show you. Code behind, which means we take the code out of the component code block and move it into a real class. Input validation, JavaScript interop, and generic components. So Band Booker is an application that I wrote before Blazor server was completely baked, but it was in enough of a preview where the component model was baked. And I said, you know, I really want to exercise my brain and learn this stuff in a real world application. So I have a band, and it's a 10-piece band. It's like a Steely Dan tribute band, but we have our own originals and everything, Franklin Brothers Band. And getting 10 people to agree to come to rehearsal is like herding cats. Getting them to agree to a gig is entirely even more difficult. And they like to do it by email and text and all that stuff, and everybody has their preferred method of communication. So I was like, well, why don't I build an application where we can have these gigs, right? Potential gigs. And I can select the venue, and I actually set it up so I could have multiple bands, right? Select multiple bands, multiple venues, and then I can say, here's the pay offering, here's the date, and the date and time, and here are the instruments that they want on the gig. And I specifically said instruments and not musicians because we have multiple musicians that rotate in and out of the band. Several sax players, you know, we might have a couple bass players, we might have a couple of drummers, keyboard players, not so much because my brother and I are keyboards and guitar, and we're the core of the band. But all these other people are not. So you put out the instruments, and it emails everybody with a link to a particular page that's just for them. And then they can come in and say, yes, they can play that gig, and here's the instrument that they'll play. They claim one of the instruments. Or no, that they can't do it, and they can give a reason. But in this demo, I'm just limiting the models to instruments and musicians. There are actually 5 models in the big version, which you can download and check out yourself at blazor.appvnext.com. And there's a video and a hands-on lab in terms of how to create it. So we have instrument, guitar, whatever, a musician, name, email, and a list of instruments that they play. And then we have bands that has all the stuff about the band, and then a list of musicians, okay? Then you have the venue, which is pretty much just static data, and then bookings, which combines a venue, a band, a list of required instruments, and you know the pay and the start time and all of that stuff. And then the booking becomes either booked or not booked when all the musicians have claimed the instruments and we've got a buy off. The irony of this application is I brought it to the band and they're like, nah, I just want to use email. So we don't actually use it. And there's no incentive for them to use it because it's just more crap for them to learn. And they don't have to do all the spreadsheets and keeping track of everybody. So I do that. So there's no incentive to use it. Anyway, that's what we're going to learn. And I'll show you the application now. We'll pull it up here. I'll close this guy. And here is Band Booker. Now we're using the same development model that I just showed you, whereas we have a version that's running in the browser and a version that's running on the server at the same time. And here is the end result. The other thing that it was not on that list that I'm going to show you is authentication and authorization. But you can see right here I'm logged in, right? A couple of different guys I'm logged in as over here. And because I'm logged in, I can see this stuff. If I log out, now I can't see it. It says please register or log in to use this app. And I'll log in again. And now I can see, oh, that's not good. Let's do this one. So you can see that the authentication and authorization is working just fine. As far as the UI, these two things are pretty similar, and they each have a component that I've defined to edit them. But just a couple of things that you'll notice here. When I select one of these guys, now I can edit or delete, whereas before, the edit delete buttons before anything is selected or disabled. If I edit, say, base, now this select, the list box becomes disabled. And I can make a change to it. So I can edit, I can delete. All of that just works fine. Musicians are a little bit different. If I edit a musician or add a musician, I get this list right here. And this is UI you've probably seen and probably written a million times before, where you have a list of all things on the left and selected things on the right, and items can only exist in one or the other, right? So Shredding Shelly plays guitar. This is a generic component. And so I'm going to show you how to build this. And because in the real application, for bands, we have to select the musicians in the band. So it's the same reusable component. So this component doesn't actually know what an instrument is. I've told it what an instrument is by giving it a list of instruments. You'll see how to do that. Here's another thing that you'll find interesting is if I'm going to add a new person or an instrument or a musician or whatever, you can see the blinking caret right there. That is because it has focus. And focus is not, setting focus is not something you can do in Blazor without using JavaScript interop right now. So it probably will. They'll probably add that to the model, but right now you can't. So that's my JavaScript interop demo. And also, if you're editing, you can see not only is it in focus, but it's selected. And that is pretty much the demo, but the demo exercises a lot of things. There's code behind in here. There's the generic component. There's JavaScript interop. There's authentication and authorization. Let's dive in and take a look. So again, everything is happening in the client, Band Booker WASM client, right there. I've got my pages. Here's index razor. First thing you'll notice is authorized view. So authorized view is a component that you can wrap markup in, and there's a view for if the user is authorized, which is all of the stuff, and then a view for the user that is not authorized. We please register or log in to use this app. So authorization, controlling what they see based on whether they're authorized, is possible. Now you can add roles to this, and so you could even say on the whole page that this is an authorized page only, and you have to be in this role to see this page. But within the page, you can have a view that only if the user is in a particular role can they see this UI. Good stuff. So we can now enable and disable buttons depending on context and requirements, right? Yes. In fact, I could do stuff like this. I could say, if all instruments count greater than 0, show some UI here. Like, right? So I have UI that's dependent on a Boolean expression. And I could just set a Boolean and look at that. So the Boolean could be set from other places. Oh, so what happened here? Oh, okay. I know what's happened here. This got evaluated before all instruments, all right, was initialized. So I'll say if all instruments does not equal null and all instruments, oh, and it's not all instruments, it's instruments. If instruments does not equal null and instruments counts equals 0, greater than 0. All instruments is something that we create and we pass to the generic component. All right, so here we have instruments. Let me delete them. No instruments today. So there you go. All right, authorized view. Also notice there's no code here. That's because I created a class called index.razor.cs. And indexrazor.cs is my, for lack of a better word, code behind. And here's how I create that. I have to include partial. Otherwise, I would have to rename this to something else. And inherit from component base, which is in this namespace right there. The next thing I have to do is change all my fields and methods that are going to be accessed by the UI to protected. They're private by default. So there's code behind, and I could do that for another thing. I could do it for counter. Let's do it for counter. We'll just add to pages a class, counter.razor.cs. And this will be a partial class and inherit from component base. And if I go out to counter now, I can delete all this stuff right here. Delete the code block, move it into my CS file. But I have to make these protected. Actually, that's private. That can stay private, but this has to be protected. No, that has to be protected also because it's used in the UI. Could also make them public. So there you go. Counter works as advertised. So that's code behind. Let's look at the component for, and all my components are in my shared folder, instrument editor. And this brings up validation. So first of all, let's go down to the model, the instrument model. And I'm using system component model data annotations here. And I've said that the name property on this instrument model is a required field and that the maximum length is 50. When I'm editing an instrument, let's go over here and edit an instrument. And I start typing something that's longer than 50 characters. Tab off that. My name is too long. If I select all of that and I tab off of it, it's required. So there's the input validation. And it won't even let me submit a change. And here's how that works. We're using an edit form, which is a Blazor component built into the framework. We have the model, edit instrument, which is my instrument. And on valid submit, we're calling submit button pressed. And in submit button pressed, I check whether we're adding or editing, and I call the appropriate event. I raise the appropriate event based on that. Okay. Now you have the data annotations validator, which means we're going to validate against the annotations in the model. And the validation summary, which I can put anywhere in the edit form. There's also tags that you can put next to each field if you want to do it that way. But a summary, this is where I'm putting it. That's the messages that are shown in red. Now I have this input text right here. And input text is also a Blazor component. And this is essentially an input. So, you know, it derives from input, but it also has the validation stuff built into it. We'll come back to this ID right there, but just remember that this input text ID is instrument.name. So now I have my submit button, and submit button text, the text in it is going to be different on whether we're adding or updating. We'll say add or update, right? And then I have another button, which is my cancel button. And this has to be described as type equals button in order for that to work. Otherwise, it will be considered a submit button. So now I have my parameters, and everything else is just pretty simple. All right, so let's talk about JavaScript, the focus event. So here's the script, and this same script is in my host CS_HTML up here. Here's my setFocus method. It's window.setFocus. That's how I call it. Now, instead of just saying element equals get element by ID and then focus and select, I'm actually doing some stupid JavaScript trick here where I'm delaying that. I'm calling it on a 10 millisecond timeout. And when I call it, if the element reference doesn't come back, it's null, it's not there, then I'm going to call myself again in 10 more milliseconds and return. And I'll keep doing that until I get an element reference. And then I'll call focus and select. And here's why I have to do that. Let's go back to instrument, what is it? New instrument button click, right? So this happens when I click add instrument. I'm setting this I'm calling new instrument on the instrument editor, and this is how I've defined that. Check this out. Instrument editor at ref equals instrument editor camel case. So I've got a reference to that component right there. So now I can call await instrument editor new instrument, and in new instrument I'm adding, I have the submit button text, I create a new instrument, and then I have this show instrument panel equals true. And that is actually the Boolean that tells me whether I want to display this form or not. So then I'm calling set focus, and I'm doing it asynchronously, but here's the thing. I've set this, I have to unwind the stack, and we have to do another refresh before another, rendering, before this will even exist, this input text right here. So somebody said to me, why don't you just, do one of these? Protected, override, async, task, on. All right, why? Let's do this one first. On after render. Oh, that's right. Okay. It's not async. Why don't you just, after rendering, now that will exist and you can call your JavaScript or whatever, why not just do it there? Well, now, every time the page renders, now it's going to set focus. And now I have to do a whole bunch of logic in here to figure out when the right time to do that is. Nah, I didn't want to do that. So that is how it works, where we have injected this IJS runtime variable for JavaScript interop, and we're calling it right there. That's how JavaScript interop works. And you could take, for example, an entire JavaScript widget that you're already using in some other application and write a component, build a component, right, that has access to that JavaScript, and then write properties, methods, event handlers for it that just wrap it with JavaScript interop. So let's talk about the musician editor, which looks pretty much the same, except we have this object picker. And this is where all instruments comes into play. Object picker is our generic component. All items is shown on the left. That's all instruments. On the right, selected instruments, the musician's instruments. This item type and item type plural, those are strings that we can use in the UI just to show what you're actually looking at. And then the name of the text property is name, right? Musician.name. And the value property is ID. So that gets passed to object picker. Here's object picker. This is what makes it generic right here. The at type param t item. So this is a table essentially, and in the table we've got on the left a list. We have double click support and on change, and now we're going through all items, and we've got these helpers, item value and item text. Well, take a look at that. It's just reflection. Item value, we call it get property of the value property name, get the value to string, and item text property name. This is how all custom controls work. They ingest that type instrument, and then they use reflection to figure out what the values are. Then we have the buttons to, swap between the lists. And then the list of selected items. And this is interesting. Right here, you can see on parameters set, I'm doing a little deduping, taking out the instruments from all instruments that already exist in the selected instruments list because they can't exist in both places at once. So JavaScript, code behind, validation. Geez, I think that's it. Authentication and authorization. We've talked about the authorization. Let's talk about the authentication. I've got controllers here. Here's an accounts controller. And the accounts controller is used for registering. And this is using the ASP.NET Identity stuff. So we've got a database that we've migrated to, that we created. And the database has the users and the roles and all of that stuff that goes along with identity. Here's the login controller. And the login controller uses the sign-in manager, right? And it returns JOT tokens, or a JOT token. There's a model here called the login result that returns a token. And then the client, let's go to the client, has an API service, an auth service rather, that is used to register and log in. And we're logging in and getting the auth token back. And then we're using this authentication state provider to mark the user as authenticated. And what that does is it saves that token in local storage. And local storage is injected right there. So it's a lot stronger than cookies. It's actually in local storage and it's protected. And that's how essentially that works. When you load it up, the JOT token gets loaded, it gets passed to login, we get authenticated, and Bob's your uncle. So it is a little more in depth than that. But as you will see on the next slide, the code for this, credit goes to Chris Sainty. Chris Sainty has a great blog, and chrissainty.com, and I encourage you to check him out. He basically, first of all, let me back up a little bit. There is authentication built in now to the WebAssembly preview and also to the server, Blazor server template. And that gives you the default UI, and it uses, whatever, it uses cookies, I think, by default. But in order to do your own UI for registering and logging in, because let's face it, I might want to have some different stuff there, you really have to roll your own. And by rolling your own, I mean not use the template, but make your own register page, your own login page, your own API controllers, and all that stuff. So all of that I got from Chris Sainty's blog post, and he gave me permission to use it. And gladly. Thank you, Chris. So just a couple of notes here. If you're going to deploy to Azure, you need to enable WebSockets on the app service configuration. This is Blazor server now. Blazor client, you don't have to do any of that. Now, we have a few minutes left. I want to talk about Developer Express free Blazor components. So give us a little shout out in the chat if you currently use Developer Express tools. Give them a little shout out. They deserve all the credit for bringing this to you. They want you to know about Blazor. They want you to know how it works under the hood. And they really also want you to take their free Blazor controls for a ride. And I'm going to show you the value of their Blazor controls based on everything that you've just seen here, the core thing that DevExpress does that you don't want to do is writing complex controls, right? You just want to get shit done, right? That's what I want. That's what we all want. I don't want to spend a lot of time writing components that I'm going to reuse if I can just drop them in. So DevExpress controls are set up for maximum productivity. They have a data grid and a pivot grid, a scheduler. Oh my God, the scheduler. Let me just show you a couple of things that they do. We'll bring this down and pull up a browser, and this is the hands-on lab that you will get if you just go download it from Blazor Desk Show. But if I go to devexpress.com/free Blazor, this is where you should go right now or right after this event and register so that you can download their tools, their free Blazor controls. They're free right now. They'll probably not be free in the future, but anything that you download and use right now, you can use forever. It's not going to expire on you. Your app isn't going to stop working. Take a look at the scheduler. This is really amazing to me. This is like dropping Google Calendar into your application. I can change, the time, the date. I can edit the details of an appointment, whatever, my start time, my end time, whether it repeats, how it repeats, description, labels, status, all of that stuff. I can add new things very easily, right? And I can, of course, overlap. I can drag and drop from day to day. Now, all of this with this markup in code. Come on. How can you not use that? You connect it to a list of dates and appointments or whatever, and that's it. It just drop it in and it works. Very impressive. Yes, I totally agree. This is good stuff. They also have a file uploader. We were just talking about that does chunked uploading. It also it does three things. There's like a static files thing for small files. There's an image uploader, and then there's a chunked uploader, which you can upload huge files that just upload in chunks, and it uses an API. Also very good. The data grid has a lot of configurability. You can also just change the Blazor Bootstrap theme very easily, and it picks up on those. It doesn't get in the way. Now I want to show you a demo that they did with Band Booker. But instead of the UI that I had created there, they made their own UI using grids. So using their grid, they basically replicated the functionality of my entire application. Here's a new instrument. I'll call this conga, and I'll update. There it is in the list, and I can edit maybe congas. Now I can create a musician. Here's the musician. His name is Che, and I can select the instruments that he plays. Here's congas. Click again. Here's keyboards, bass, maybe not keyboards, but bass. And then I update. There's Che. When I edit, there are his instruments, right? So now let's take a look at what that looks like. Here's the markup. All right. Markup for the instruments. markup for the musicians, a little more complex because it has that form, but still not a lot of markup. And let's look at the code. Here's the code to support the instruments. And here's the code to support the musicians. Again, manageable. Very, very manageable. And the function, while all the bells and whistles aren't there, the functionality is there. So if you just want to, knock out some crud stuff, give them a grid. It's pretty easy. Now, my friend Don Webiar, Don Weavier, he is going to show us now a little demo. Oh, no, before, I have to show the demo first, don't I, Don? Before you come on here. Let me go back here. I want to show you the difficulty in doing a list box, a multi-select list box. Here I've got a demo. Now, the single select list box is everything that I've been showing is the single select list box. But you might think that with, this select, that I could just do a multiple on that, and then my selection, this change event args, would pass all of the items that were selected. But it doesn't happen that way. It's not supported. So I found, I'll show you the easy way. I'll show you the hard way to make this happen, and then Don will show you the easy way. So first of all, let me talk about what this is, the coronavirus shutdown reading list. So this is a single select, just like I had before. If I press Control or Shift, nothing happens. But I have some nice books here, like Practical Snow Melting for Fun and Profit, How to Shave a Cat, and Winning at Tic-Tac-Toe. Now, I found a way on the internet. Some guy had written this elaborate generic control and a whole bunch of JavaScript to do multi-select, and here it is. So I can hold down Control, and now I can select more than one. I can hold down Shift and select all. There you go. That's what you want in a multi-select list box. But here's what's involved in making that. So here's the markup. We have a component he calls select multiple. And here's my code. So there's not a whole lot of code in markup here, but select multiple itself is a little hairy. So also I completely stole this from Ash KE98 on medium.com. There's the there it is right there. It's a public blog post, and he gives his code away, so I don't feel bad about it. So this is all the stuff that is required in order to do a multi-select list box, including some hellacious JavaScript. Look at all this. So there's a lot of if, then, else for cyclomatic complexity here. And then there's also this, there's some code that gets called from JavaScript. So where is it? Yeah, right down, select multiple, yeah. This guy is JS invocable, so on option select actually gets called from the JavaScript. So there's a lot of code there just to support multi-select list box. What I really want is something that I can just drop in and use and reuse, because, okay, multi-select list box is fine, but what about the next thing that comes along? So now, my friend Don Webier.
Hey Carl,
Dev Express.
That was a decent amount of work getting that multi-select feature enabled. Yeah. But fortunately, there are easier ways of doing so by using the native Dev Express Blazor controls. And let me show you how simple that works.
Okay.
I have this page over here, and I have only prepared this property which will hold the selected books of the list box.
Yep.
And what I'm going to do, I'm going to insert the DevExpress list box here, where I will bind the data to the book service, and I'll specify a text field name, which will be in this case the property name, which will be displayed inside the list box. And then the last thing is I'm going to bind the selected items of the list box to the selected books property of the page. And this is basically all we need right now. Let me also include the code that you've seen before. There is one difference though, and that is instead of cycling through this list with IDs and stuff, you can now cycle directly through the selected books collection. And you can write out those property names straight away. So it's again a bit less code here. And once I run the application, let's see what happens now. If I go to the DevExpress demo, what we'll see is that we have the same UI as we had on the previous pages. The only thing right now is that if I hold down the Shift key or the Control key, it still selects one. Well, and that's actually quite simple solved, because right now the list box is in single selection mode. If I go back to the code and I'll add a property which I will change to the list box selection mode multiple, we're all set. So let's run a demo again, and I will now be using my Control and my Shift key as well. And what you'll see is I can select items individually or deselect them, or I can even hold the Shift key to select the whole batch. So that's quite simple, huh? And there is one more thing I'd like to show, and that is setting another property. And that property is going to be show checkboxes. I'm going to put it to true, and now all of you may guess what this will do. So let's run it again, and what we have now is a really nice list box with checkboxes. And for single selections I don't even need to hold down the Control key, but I can still use the Shift key if I want. So if I want to select the whole batch, I'll just hold down the Shift. So a very nice and powerful control. And yeah, if we check the amount of code that was needed to get this desired UI, I would say this is too much, right?
Yeah, it's great. Don, thanks for the demo.
You're welcome, Carl, and we'll talk later.
All right, very good. Bye-bye. So thanks, Don, for that. Really good stuff. As I said before, DevExpress really wants you to take their stuff for a spin. And to do that, you register at devexpress.com/freeblazor. You get a private NuGet feed, GUID, basically. You set it up as a private NuGet feed in Visual Studio. Very easy to do. Install the packages, add a style sheet, and import DevExpress Blazor, and you're off to the races. So there are some roadmaps here. Resources here are Blazor roadmap at DevExpress to keep up with latest developments, and a portal where they talk about new features and things. And get in touch if you have any questions about DevExpress controls or Blazor. We all see this Blazor Roadshow at devexpress.com, or just Blazor at devexpress.com. So go get your free copy right now, devexpress.com/freeblazor. And I would like to officially thank you for watching the Blazor Roadshow. The Blazor Desk Show today. And don't be a stranger. We'll see you out there. All right? Thanks.